Let's show for the standard normal distribution z, that's a random variable, then e of z squared is going to be some value that we want to find out. So let's go ahead and calculate that. So the expected value of z squared is 1 over square root of 2 pi. Then we're going to have to integrate from minus infinity to infinity of x squared times e to the minus x squared over 2 dx. So instead of z, I put x's just for ease of calculation on my part. What I'm going to do is do integration by parts. U is going to be x, dv will be x e to the minus x squared over 2. The reason why we do that is that when we integrate this, we get e to the minus x squared over 2. You can check that. E to the power e to the minus x squared over 2, take the derivative, minus 2x over 2, and you get a minus x. So we have x negative e to the minus x squared over 2, the uv, minus, which would be a plus, the integral from minus infinity to infinity of e to the minus x squared over 2 dx. Now I left off my 1 over square root of 2 pi. So let's just put that 1 over square root of 2 pi out here times this whole thing. Now I have to take this integral and I'm going to go from minus b to b of this one. Take the limit as b goes to infinity for this. In both cases, as b goes to infinity, exponential growth will swallow up linear growth, and so we get 0 there in both cases, putting in positive b and negative b. So this will be 0. This right here, remember, is just what we did in an earlier video, that this is just the square root of 2 pi. So altogether we get 1. Now, some other time we will show that the expected value of the mean is actually 0. One sort of way that you could see that is that the expected value of z would be 1 over square root of 2 pi. This is not necessarily a good proof, but we have x e to the minus x squared over 2 dx. This is just sort of heuristic why that is. This right here is an odd function. So what that means is, like sine of x and other things, f of the opposite of x is the opposite of f of x. And since it's symmetric on this part, you get 0. You know, sort of like if you integrate from minus 3 to 3 of x cubed dx, you get 0, because you go from minus 3 to 0 of x cubed dx plus 0 to 3 of x cubed dx. Well, that's the same thing if you do a change of integration, of limits, I mean. You get minus 0 to 3 of x cubed dx plus 0 to 3 of x cubed dx, and you get 0. And that's partly by the symmetry part. So altogether then, the variance of the standard normal distribution is e to the x squared minus e to the x squared, or 1 minus 0, or 1. And you can change this if you had the a generic normal distribution by doing your change of variables z minus x, x minus mu over sigma. And you might have something like dz is equal to 1 over sigma dx, and you can change it to the standard normal distribution. But the big part is that the variance of z is indeed 1, which is also the inflection points of the curve.